Good morning, students. Today from class 11th we'll study about the how to find the form of the complex number and how to find the to find the polar form of the complex number, plus how to find the modulus and argument of the complex number. Let's try from the exercise, that is 5.2. Exercise 5.2, and we have a chapter that is complex number. Now we'll try to solve the numerical directly from the exercise. What they have given is we need to find the modulus and argument of the given complex number. Okay, so what they have given, first question they have given, that is z is equal to -1 minus I root 3. Okay, so that's the question is. Now let us try to solve it. Now they have given the complex number, that is z is equal to -1 minus I root 3. So here I have two things, that is a real number and a imaginary number. So here we'll try to find, that is they have given r cos theta is equal to -1, r sin theta is equal to minus root 3. Now they have given both. So now what we will do, squaring and adding both. Squaring and adding both. So what we get here is r square cos square theta plus r square sin square theta is equal to -1 square plus minus root 3 whole square. So what I got here, sin square theta plus we have here cos square theta. Here I am taking r square is common. Now here we have 1 plus 3, that is 4. So you know r square into 1, because sin square theta plus cos square theta is equal to 1 we have here. So now r square is equal to 4, therefore r is equal to 2. So we got our modulus, that is 2. Now we'll find the angle here, that is they have given -1. So r we know 2. So cos theta is equal to -half. And here if I go for it, that is sin theta is equal to minus root 3 upon 2. Both are negative now. Now to find the argument we have. So argument will be, both are negative, so we'll move here minus pi minus we have, we'll take the angle, that is 30 pi by 6 we have. So it will be minus pi by 6 we have. Okay, so they have given here, that is it will be minus pi by 6. So we can see here, if I take here, that is if I take the 5 pi by 6, so 5 into 180 upon 6, 630, so it will be 150 degree. So we will take this minus pi by 6. So this is a argument, and here we have found the modulus, that is 2. So that is how we try to find the modulus and argument. Now let us move on to the second question we have. Okay, now let us try the second question we have. So what the second question says, let us see. The question is, that is a complex number minus root 3 plus I. Okay, minus root 3 plus I. So we have r cos theta is equal to minus root 3 and r sin theta is equal to 1. Okay, so they have given this. Now we'll try to, what we'll do, squaring and adding. Okay, squaring and adding. So let us see what will happen. R square cos square theta plus r square sin square theta is equal to minus root 3 whole square. plus 1 whole square. Okay, so now there we can take r square as common. So we have cos square theta plus sin square theta is equal to 3 plus 1 is equal to 4. So therefore r is equal to 2. Okay, so we have here r is equal to 2. We know the identity, that is sin square theta plus cos square theta is 1, which we have studied in class 10th. Now we have r is equal to 2, that is we have got a modulus, that is 2. Now we'll try to find the angle here, minus root 3. So we have cos theta is equal to minus root 3 upon 2 and sin theta will be half. Here we have noticed one thing, that is sin theta is positive and cos theta is negative. It will be only in second quadrant. So we have argument that is here will be, okay, we have this. Now argument will be, that is theta will be pi minus pi upon 6. Okay, because sin 30 is half. So we'll have this pi minus pi upon 6. So we can say it is in the second quadrant. So it will be 5 pi by 6. So that is how we try to find the modulus and the argument of the given complex number. I hope it's clear to everyone. So now we'll try another question from this exercise. So what they have given, let us see. We need to convert now. Third question we have, and the question says that is the question they have given, that is we need to convert the given complex number, convert the given complex numbers in polar form. Now we need to convert them in polar form. Let us see how we can do. First complex number they have given 1 minus I. So this is the third question. They have given z is equal to 1 minus I. So here we can say r cos theta is equal to 1 and r sin theta is equal to minus 1. Okay, so now what we will do here, we'll try to do the same thing, that is squaring and adding. Okay, squaring and adding ahead. What we'll do here, r square cos square theta plus r square sin square theta is equal to minus 1. So we have r square, we'll take common r square common, so we have sin square theta plus cos square theta, okay, is equal to minus 1. So now r square into, what we have here, we have to add, so what will happen, minus 1 square plus 1 square. So here we will have 2, 1 plus 1, 2 we have. Now into 1 is equal to 2. So therefore r is equal to 2. That is, now we got the value of modulus. Now we'll find the value of angle. So we have r cos theta is equal to 1, root 2 cos theta is equal to 1. We have cos theta is equal to 1 upon root 2. Okay, so now they have given this, and here also we have r sin theta is equal to minus 1. So root 2 sin theta is equal to root 2 sin theta. Okay, now what we have here, root 2 sin theta is equal to minus 1. So we have sin theta is equal to minus 1 upon root 2. Now we know that the sin is negative and cos is positive in fourth quadrant. So therefore theta will be pi upon 4 here. Okay, so we have the value, that is pi upon 4. Now we'll try to find the polar form. So we have this r cos theta, what is r, root 2 cos pi by 4. We have root 2 cos pi by 4 minus we have here 1 minus we have r sine theta. So what is r here? We know root 2. And what is theta? Pi upon 4. So we can take root 2 common as cos pi by 4 minus sine pi by 4. So this will be our polar form of the given complex number. Okay. So now let us try to solve more. Now this is the third question we have solved. Now we have the fourth question. So what the fourth? Let us see what in fourth they have given. Minus 1 plus I. Okay. Minus 1 plus I. So we know that is r cos theta is equal to minus 1 and r sin theta will be 1. So now we have this, that is, what will be the next step? Squaring and adding. Okay, so we have this. So we have r square cos square theta plus, now we have r square plus cos, that will be minus 1 square plus 1 square. So we have, we'll take r square common here. So we have sin square theta plus cos square theta is equal to 1 plus 1 2. So therefore r is equal to root 2. So finally here we have found the modulus. Now we'll try to find the angle here. So we have this root 2 cos theta is equal to minus 1. So cos theta is equal to minus 1 upon root 2, and root 2 sin theta is equal to 1. So we have sin theta is equal to 1 upon root 2. We know that sine is positive and cos is negative and second quadrant. So the angle will be, that is, if I find the theta, it will be pi minus pi by 4 we have. Okay, so we'll take as it is, that is pi minus pi by 4. So here the angle will be, that is 3 pi by 4 we have. Now we'll try to write the polar form of this complex number, that is root 2 cos theta plus root 2 sin theta. Sin theta, sorry, theta we have already found, that is 3 pi by 4. Here we'll write as 3 pi by 4. So you can take root 2 as common. So cos 3 pi by 4 we have plus sine 3 pi by 4. Okay, so like this we can find the polar form of the complex number. Let us move ahead to solve more numericals. That is, we need to find the polar form of more complex number which I have given. So now we have just solved only 4. Now we'll try to solve 4. That is fifth one now. Okay, what the fifth one says, let us see. They have given in this. So the fifth is about the complex number they have given, minus 1 minus I. We have this minus 1 minus I. First of all, we will find r cos theta is equal to minus 1 and r sin theta is equal to minus 1. Now both are negative they have given. First of all, the first step is squaring and adding. Squaring and adding. Let us move. Squaring and adding we have. So what we will do? We will try to find the squaring after adding, that is what, r cos square theta plus r square sin square theta is equal to minus 1 square plus minus 1 square. Okay. So now what we have here, we'll try to take r square as common. Now we have 1 plus 1 2. So therefore we got r is equal to root 2, because we know that sin square theta plus cos square theta is 1. Now we have r root 2. Now we'll find, that is, we've got the modulus here. Now we'll try to find the value of angle. Here we know that they have given minus 1 upon root 2. And also for sine theta we have -1. So we can see here that both the angles are negative. It will be, they will be in fourth quadrant. So theta will be minus pi upon 4. Now we know that after finding the theta, we will try to write its polar form, that is r cos theta, that is root 2 cos minus pi upon 4 plus root 2 sine minus pi upon 4 we have. So we can take root 2 common. So we have cos minus pi upon 4 plus we have I also here. So we will write I sine pi by 4 minus sorry. Okay. So that is what we find the polar form of the given complex number. Now let us try to find the polar form of the given complex number we have, that is -3 we have now, and this we have z is equal to -3. They have given -3 only. So now, but how we'll try to solve? We have r cos theta is equal to 0 and r sin theta, no, it's -3 and here it is 0. So now the same step we have to follow, that is squaring both sides. Squaring and adding we can get right. Okay. So what will happen? We have, that is r square cos square theta is equal to 9 and plus we have r square sin square theta is equal to 9 plus 0 will be 9. So we can easily say, so we have this 9, so therefore r we got 3. That is, we got the value of modulus. Now we'll find the angle here, that is 3 cos theta is equal to -3. So we have cos theta is equal to -1 and 3 sin theta is equal to 0. We have sin theta is equal to 0. We know the value, that is cos theta -1 and sin theta 0 will be pi. So theta is equal to pi. Now write the polar form. We have 3 cos 3 cos pi plus I 3 sin pi. So that is how we write the polar form of the given complex number. Okay. So now let us try to find more. So we have just solved 6. Now let us try to solve the 7th. So we have solved 6 numericals directly from the exercise. That is, now we need to begin with 7th question we have, that is root 3 plus I. So this is a given complex number. Okay. So now let us try to find, that is, we have z is equal to this much now. So now r cos theta is equal to root 3 and r sin theta is equal to 1. So now squaring and adding. Okay, squaring and adding. So how to do it? Let us try. R square cos square theta plus r square sin square theta is equal to root 3 square plus 1. So we have r square common, that is sin square theta plus cos square theta is equal to 4. So therefore we got a value of r 2, that is what we got here, the value of modulus. Now we know the value of modulus. Theta is equal to 1. So we have sin theta is equal to 1 upon root 3. We know that both are positive in first quadrant. So therefore we can say r theta. So wait. Here I have done a mistake here. That is 2 here. So it will be half here. So therefore theta will be what? Pi upon 6. Cosine 30 is half and cos 30 is root 3 upon 2. Now we have find both the values. Now we'll try to write its polar form. So it will be 2 cos pi upon 6 plus I 2 sine pi upon 6. Okay, so that is what we have find the polar form of the given complex number. Okay, so now let us try to solve the 8th question now. So what the 8th question says, they have given the complex number that is I. Okay, so they have given the complex number that is I. So we'll write as r cos theta is equal to 0 and r sin theta is equal to 1. So what we will do? Squaring and adding. Okay, we have squaring and adding. So what we got here? R square cos square theta plus r square sin square theta is 1. So we have r square cos theta, taking r square common here, plus sin cos square theta sin square theta is equal to 1. So therefore we have r is equal to 1. Okay, because we know the value of root 1 will be 1 only. So now after finding the modulus, we'll try to find, that is cos theta is equal to 0 and sin theta is equal to 1. So theta will be pi by 2 because we know that the cos 90 will be 0 and sin 90 will be 1. So now we have found out theta. So its complex form will be cos pi by 2 plus I sin pi upon 2. So now, so this is how we can convert the following complex number into polar form, where they have cos theta with the real number and sin theta with the imaginary number. So that is how we convert the polar form, convert the following complex number in polar form. And we have learned today, we have understand today about how to find the modulus and argument of the given complex number. So I hope it's clear to everyone. So if you have any doubt, you can ask, comment, share, and also please like my channel.